13.3 asks to determine the number of units of product A and product B that the manufacturer needs to produce in order to maximize his daily profit. A diagram is provided on the diagram sheet. My graph is a bit small, but I'll refer to it. So you need to look at your diagram sheet quite carefully, where the feasible region is quite clearly marked. Now, the answer to maximize our profit has to come within that shaded feasible region. We know in order to find a maximum value, we're going to be on the extremity of our feasible region. And what we need to do is we need to find out the gradient that we use in order to have our maximum profit. Now, this is a profit equation that we've written before. Let's get it into the standard form that we like straight line graphs to be in. So if I switch over, I'm going to get minus 40y equals 30x minus p. The sign of p doesn't really matter, but y will be equal to minus 30x over 40 plus p over 40, because if I divide this minus away, it's going to be minus p divided by minus 40, which will become plus 40. So my graph is going to be minus 3/4 x plus p over 40. So what we have is we have a graph which demonstrates the profit that we are going to earn, and this is what the graph looks like. It's going to have a graph of a slope of minus 3/4, and I've drawn here what a slope of minus 3/4 will look like, with a rise of 3 and a run of 4. And so what you do is you take your ruler and you line up the 3 and the 4 on your graph axis carefully, so that the 3 is on the y-axis and the 4 is on the x-axis. And then you run your ruler up parallel to where you start until you get to the last point in the feasible region, which should be there if you do it carefully. And so at the point which I shall call here A, you will have a maximum value for your profit. And if you run down the graph to the x-axis, you will find that that gives you an x value of 3 and a y value of 5. So this point here on your graph should be 3 and 5. So the maximum is at 3 and 5.